Good evening, guys. It's Mr. Lamb, and here is the key to the Unit 6 review test. This is Unit 6 review number 2. As I said, this is going to have a lot of materials from the previous Unit 6 test, one we took before Christmas break. So those topics will be on here if you need a little bit of extra direction or would like to check your old test from that test. Don't forget, you can go back, and that video key is in Canvas as well. This test score will replace your old test score unless you had an A. If you had an A on the original Unit 6 test, I will not take that A away from you. You'll be able to keep that A. But if you outscore that A, I will give you the higher of the two A's that you earned. Other than that, you will be taking a new test score as we move forward. So without wasting any more time, let's jump right in on this problem. And number one is a partition question. This is some of the new stuff that we've done. So I do want to partition AB, so I'm going to start by graphing AB. So -2, 4 is A, and 6, -8 is B. And there's my segment. So first thing I want to look at is I look at the ratio. It says a 1-to-3 ratio. That tells me I need 4 pieces. I get the 4 because 1 plus 3. I add the two parts of that ratio together. Whatever those two numbers are, 1 plus 3 is 4 pieces. And then I'm going to look into the rise and the run. So I need to find the change. And I am going to talk about the change in the x values, and I'm going to talk about the change in the y values. Now I know that when we do slope, we always do change in y over top of the change in x. But really, I'm not finding the slope here. I'm just writing down what that change is. So let's find the change in the x value. So to get from A to B, I have to go to the right. And I have to measure how far I'm going. So that's 1, 2, 3, 4, 5, 6, 7. That is 8 units in the right direction. Right? If I'm moving to the right, that is positive. So the change in the x right now is a positive 8. The change in the y then starts going down, which I know is negative. So that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It goes down 12. So my change in y is -12. Okay, now that is the overall slope. That's from one endpoint to the next. Now I know that I need to cut this into 4 pieces, so I'll divide both of these numbers by that 4. And that's the 4 coming from that ratio 1-to-3. All right, so 8 divided by 4 is actually 2. So instead of going right 8, I'll start going right 2. And -12 over 4, instead of going down 12, I'll go down 3. All right, so I'm starting at point A and moving to point B. So I'll start with point A, which is at -2, 4. And I'm going to work my way down to point B, which is at 6, -8. Now, if you want to know how many points are in between, we do have a little shortcut. You can take the number of pieces, which is 4, and subtract 1. That'll tell me how many points are in between. Or I can just start working my way down. I really don't care. Because I know this, I'll go ahead and I'll put in, I know that there are going to be 3 points in there. And my x's. So as I look right here, my change in my x values is +2. That means I am going to add 2 to my x values. So my first x value is right here. It's -2. -2 plus 2 is 0. 0 plus 2 is 2. 2 plus 2 is 4. And 4 plus 2 is 6. All right, now I'm going to go to my y values. My first y value is 4, and I want to change my y's. I change a y by subtracting 3, -3. So 4 minus 3 is 1. 1 minus 3 is -2. -2 minus 3 is -5. And -5 minus 3 is -8. So I know all of my points are correct now. I know they're right. So now I'm going to find the ratios for each one of my points. And I'm actually going to find them all because I really do think this helps. I don't worry about the ratios on the 2 points I started with. The ratio for this first point, as I look at the point, I count the number of points above it. There is 1, it's point A. And I count the number of points below it. Well, there's 2, -2, 4, -5, and 6, -8. There are 3 points below it. So that is a 1 to 3 ratio. As I jump down here, the point 2, -2. How many points are above 2, -2? There are 2. And there are 2 below it. So that has a 2-2 ratio. This point down here has 3 points above it, 1 point below it. It's a 3-to-1 ratio. And then the last one is one of the points that I started with, and I don't give those ratios. So this problem asks for which ratio has a 1 to 3 relationship. And there are actually 2. I see the 1 to 3 ratio for 0, 1. This is one of my proper answers. That's a correct answer. And the other one would be that ratio turned backwards. So 1 to 3 or 3 to 1, it really doesn't matter. They are both the same. So those 2 points that would partition the segment AB into a 1 to 3 ratio are the points 0, 1 and the points 4, -5. Yes, you can get there by looking at the slope. If I know that I have to go right 2 and down 3, I can start at point A, go right 2 and down 3, and you'll see that point right there is at 0, 1. Go right 2 again and down 3 more, and you'll see the point at 2, -2. Go right 2 and down 3 more, and you'll see the point at 4, -5. Right 2, down 3, you would be at point B. So you could do that one graphically. It's nice graphically when those numbers, this 2 and this -3 over here, when those numbers are whole numbers, then the graphing method works really well. If they are fractions, like 1/4 or 4/5 or 2/7 or something like that, then the graphing method really becomes pretty difficult. All right, so number 2, same kind of problem. I'm not going to do as much explaining. I'm going to kind of just go through this one now. Point A is at -3, -2. Point B is at 4, 1. Find the number of pieces. It is a 1 to 3 ratio, so I have 4 pieces again. Find the change in X and the change in Y. Some people ask, why do I do change of X first? And it's only because if I do change in Y then change in X, I always end up making a mistake. And I start doing my X's first and I add or subtract the wrong number, that's all. So change in X from A to B, it's going to the right. So that is 1, 2, 3, 4, 5, 6. That is going to the right 7. And then it's going up 1, 2, 3. So the change in X, since it goes to the right, is +7. It is going up, so it is +3. And I need to cut that into 4 pieces. And these are going to be some decimals now. So 7 divided by 4 is 1.75, and 3 divided by 4 is 0.75. All right, so 4 pieces. Start with A. The first point is -3, -2. I'm going to work my way down to point B, which is at 4, 1. All right, my first point. I take my X and I have to add 1.75. To add 1.75. So -3 plus 1.75 is -1.25. To get the next point, I add 1.75 again. And I get 0.5. I add 1.75 again. I get 2.25. And when I add 1.75 again, I get 4, which is the answer that I want down there in B. Now for my Y values, I start at -2 and I'm going to add 0.75. That is -1.25. and then I'm going to add 0.75 again. That is negative 0.5. I'm going to add 0.75 again, and that is 0.25. And then I add 0.75 again, and I get 1, which is the answer in B that I wanted. Now it's time to look at ratios. First point I find right here. This point has 1 point above it, has 3 points below it. That's a 1:3 ratio. This point has 2 points above it, 2 points below it. That's a 2:2 ratio. This point down here has 3 points above it, 1 below it. That's a 3:1 ratio. My answer wants the one that is 1:3. This one here is 1:3, as is the 3:1. Those would be the 2 points I'm looking for. All right, number 3. There is one of these on the test as well. Determine if the quadrilateral with the following vertices is a trapezoid. Justify your answer. And I have to justify it by finding slopes and or distances. So this just asks, is it a trapezoid? So let's first graph these points. -8, -4 is M. -5, 1 is A. 1, -5 is T, and -2, -10 is H. Now, in order for this thing to be a trapezoid, I need 1 pair of congruent and 1 pair of non-congruent sides, which means I need to look at slope. And the only thing I care about is slope. All right, first segment I'm going to look at is segment MA. From M to A, I have to go up 1, 2, 3, 4, 5, and I have to go right 1, 2, 3. So slope is rise over run. So I rise up 5 and I run over 3. All right. If there were a side that's going to be parallel to MA, it's going to be the side that is opposite of MA, which is going to be TH, right, or HT. So I'm going to go look at HT now. And I'm going to make my right triangle. I'm going over and I'm going up. So I'm going over 1, 2, 3, and I'm going up 1, 2, 3, 4, 5. So again, it's a rise over run. So I rise 5 and I run 3. These two sides have the same slope. They are parallel. That's good. In order to be a trapezoid, I do need 1 pair of parallel sides. Now I need the other pair to not be parallel. I need something else. No parallel. So what are my other 2 sides? MH. Get from M to H. Let's make my triangle. All right, from M to H, I'm going down 1, 2, 3, 4, 5, 6. I'm going down 6, going to the right 1, 2, 3, 4, 5, I'm going to the right 6. So because it's down 6, that's -6 to the right 6 over 6, which reduces to -1. All right, side opposite is AT. Make my triangle. From A to T, it goes right 1, 2, 3, 4, 5, 6. Going down 1, 2, 3, 4, 5, 6. So rise over run. It looks like it drops down 6, -6 over the run. Going to the right 6 is +6, which is -1. As I look at MH and AT, -1, -1, these two things are parallel. This has 2 sets of opposite sides parallel. The name of this object. This is a parallelogram. It is not a trapezoid. This is a parallelogram. So is this thing, is it a trapezoid? No, it is not a trapezoid. In order to be a trapezoid, one of those pairs cannot be parallel. One is not. So this is not a trapezoid, it is a parallelogram. Just for those of you that are kind of thinking ahead, is this thing a rectangle? Is this thing a rectangle? Well, in order to be a rectangle, I take a look here and here. And I ask myself, are those things opposite reciprocals? And 5/3 and -1 are not opposite reciprocals, so this is not a rectangle. Those are not right angles in there. So this thing is just an ordinary, everyday parallelogram. Nothing special about it other than the fact that opposite sides are parallel. So answer, no, it's not a trapezoid. Hope that helps.